Welcome back to Beyond Binary, the channel where we decode the world through facts, science, and the fine line between innovation and consequence. Today, we're diving into something that's burning through every headline, every conversation, and quite literally, our planet itself. September 2025 has officially been declared the hottest September in recorded history. But what does that mean? Is it just another seasonal anomaly? Or are we crossing into a new era, one scientists have long warned us about, the climate tipping point? Let's take a journey through the facts, the science, and the unsettling truth about what's happening to Earth right now. In the last few decades, average global temperatures have been steadily climbing. But 2025's September wasn't just warm, it shattered multiple records simultaneously. From India to Italy, from the Sahara to Siberia, the mercury soared. Ocean temperatures hit unprecedented highs. Coral bleaching returned to levels unseen since 2016, and glaciers that were expected to last decades are now melting in mere years. Satellite data from NASA and the European Space Agency revealed that the global surface temperature this September was nearly 1.7 degrees Celsius above the pre-industrial average. That might sound small, but in climate science it's enormous. It means more extreme storms, unpredictable rainfall, and ecosystems pushed to their limits. But before we talk about the tipping point, let's revisit something else that happened not too long ago. The global shutdown. Now, when we say shutdown, most people immediately think of government shutdowns, like when the US government halts non-essential services. But the global shutdown of 2020, triggered by the COVID-19 pandemic, was different. It wasn't political, it was planetary. For the first time in modern history, industrial production, transportation, and energy consumption dropped on a massive scale across the globe. Planes were grounded, factories went silent, and cities stood still. It was an eerie pause button on civilization. The immediate effect? Air quality improved dramatically. The skies over Delhi turned blue, carbon emissions dropped by nearly 7% worldwide, and satellite images showed cleaner air across continents. It was the first time humanity witnessed, in real time, how quickly the planet could begin to heal if we stopped feeding it pollution. But that healing was temporary. When industries restarted, emissions bounced back, harder than before. Many countries doubled down on production to recover economic losses. The post-shutdown rebound pushed carbon output to record highs by 2023. The result? More heat trapped, more ice lost, and more instability in global climate systems. So, what exactly is a shutdown, scientifically and economically speaking? A shutdown is a large-scale halt of normal activity, whether due to health crises, political gridlocks, or natural disasters. It disrupts the global supply chain, slows GDP, and affects every layer of society. But its most striking effect is on the environment. During a shutdown, fewer vehicles move, factories emit less, and the Earth gets a brief exhale. However, these temporary drops don't fix the root problem, they only pause it. Think of it like taking your foot off the accelerator for a moment while still driving toward a cliff. Now let's return to the present, September 2025. This heat wave wasn't random. It was fueled by a combination of natural and human-made factors. First, El Niño, a cyclical warming of the Pacific Ocean, returned with unusual intensity this year. It amplifies global temperatures and disrupts rainfall patterns across continents. Droughts in Asia, floods in South America, and erratic monsoons in India, all connected to this oceanic phenomenon. Second, greenhouse gases continue to accumulate in the atmosphere. Despite renewable energy adoption, global fossil fuel usage is still rising, driven by industrial demand and urban expansion. Carbon dioxide levels surpassed 427 parts per million this year, the highest in human history. Third, deforestation and land use change are still rampant. The Amazon lost another significant stretch of rainforest in 2025, reducing one of the planet's biggest carbon sinks. At the same time, melting permafrost in the Arctic is releasing methane, a greenhouse gas nearly 80 times more potent than CO2 in trapping heat. Combine all of that, and you get what scientists call compound climate feedback, a chain reaction where warming causes more warming. The Earth's natural cooling systems, ice caps, forests, oceans, are failing faster than we can restore them. So when experts warn about a climate tipping point, what they mean is this. It's the moment when global warming becomes self-sustaining. Even if humans stopped emitting carbon tomorrow, the systems we've disrupted would continue releasing heat-trapping gases on their own. It's a point of no easy return. But here's where it gets more complex and more human. The world isn't facing just environmental shifts, but social and political ones too. As heat waves intensify, climate migration is rising. Entire communities are being displaced by floods, fires, and droughts. Economies dependent on agriculture are crumbling under unpredictable weather. Water scarcity is becoming the next oil crisis, and food security is under threat. This September, several regions including Southern Europe, parts of China, and the American Southwest reported energy shutdowns due to grid overloads caused by record temperatures. It's an echo of that earlier global shutdown, but this time driven by nature, not necessity. And just like the pandemic shutdown, it's showing us how interlinked our systems are. When factories can't cool their operations, production halts. When crops fail, markets spiral. When the grid collapses, hospitals and data centers, our digital backbone, suffer. It's not just a weather problem anymore, it's a systems problem. Now, here's the paradox. Technology, the very thing that contributed to industrial pollution, is also our greatest hope. Artificial intelligence is being deployed to optimize energy use, forecast extreme weather, and design carbon-negative materials. Quantum computing is being tested to model complex climate data in seconds. Renewable energy storage systems are advancing faster than ever before. But all these tools depend on one critical ingredient: collective will. Because while technology can simulate a better future, only policy and people can create it. We often talk about climate change like it's a faraway storm, but it's here. It's happening now. And the hottest September in history isn't just a record, it's a message. The shutdowns of the past gave us a glimpse of what global change can look like, both in silence and in recovery. But if we keep waiting for nature to shut us down again, it may not be temporary next time. So, are we nearing the tipping point? Maybe. But tipping points aren't always collapses. They can also be turning points. If 2020 showed us what the world looks like when it stops, 2025 can show us what it looks like when it starts moving in the right direction. Cleaner energy, smarter AI-driven infrastructure, and conscious consumption aren't futuristic dreams, they're immediate survival strategies. The choice isn't between economy and ecology anymore, it's between delay and direction. Because the climate doesn't negotiate and the planet doesn't pause, it reacts. And that reaction is already unfolding. So the question isn't, can we prevent it? It's, how fast can we adapt? And how much are we willing to change before we run out of time? This is beyond binary. Stay curious, stay conscious, and keep questioning the world around you, because the answers are rarely black or white. They're somewhere in between.